All right, welcome back to perhaps our final episode in this series on the basics of engineering. Let's just recap once again what we've talked about, an overview of the different terms, then thinking about energy, different forms of energy, energy expended over a time or rate is power, and then a little bit about forces, looking at forces and torques. Last episode, we talked about simple machines. And what we're going to talk about here is just sort of an overview of the idealizations that we make. And what that means is we try to make things simple, first off, and then we get to reality. So let's just sort of start off. We talk about the motion of an object, all right? You apply a force on it, and how far is it going to go? Or maybe you don't even look at force, you're just saying an object is moving at a certain velocity. Okay, we didn't talk about this, but there's position, there's velocity, and acceleration. Okay. Then you go from one point, when we talked about this earlier, you have projectile motion. Right, so you launch an object, it has a certain weight. We assume it's a single point. We look at the x-axis and the y-axis, and how's it going to move? All right, and then the next thing is we talk about a rigid body. And we say rigid because we're saying it's not going to bend. And that assumption will get loosened later. And so you have a rigid body, but now it's no longer a single point. So if you apply a force that is not at its center of mass, then it's going to rotate. And we know that intuitively. Now, I alluded to earlier that you have this rigid body, and you're saying that no matter how much force you apply, right, let's say it's around some sort of pivot, that this is always going to stay straight. And we know in reality that's not the case. If we think back to levers, I believe Archimedes said that give me a lever long enough, all right, and I, Archimedes, will be able to move or carry the world. Now, what we learned is that if this is really, really, really heavy, if we place it close to the fulcrum, and then if we have a really, really, really long lever, you can apply a force to move it. Now, if we think even without that sort of hyperbole of trying to lift the world, if you have, let's say, a bowling ball, and you had a meter stick, and you're trying to apply a force, as you apply force, this thing will actually bend. Okay? And you know that if you bend far enough, all right, then it's going to break. And so that's another assumption that in engineering that you may need to consider. And so you can really think as you're learning physics, as you're learning engineering, you're adding more and more aspects of reality to make things actually work. So we talked about one dimension, moving in two dimensions, then the fact that things rotate, then the fact that things bend and break. And there's all these engineering properties, right? And there's some videos on that we can watch, such as stress, strain, and specific ways to measure how tough something is. All right. In our everyday life, in our automobiles, in the consumer products, engineers, designers, they think about what material to use. And so we think about wood, to plastic, to metal, to ceramics, right? And there's, of course, all different types within those categories, depending on what you want. And of course, to be able to make something at a cost where the consumer wants to buy it, but then the company can make a profit. And of course, the company pays workers. And it's just this much bigger picture. All right, that's sort of reality. Okay, what else? I just have sort of a list of assorted things to think about. Let's say you have this magical machine here that you apply a force to over and over again. Well, over time, it's going to wear away. And so we sort of think of the lifetime of your machine. And that's why A car needs to be maintained, whether you do it at home or you're bringing it into the shop, and often people get upset at how much it costs. And yeah, you could do it at home, and many things are learnable, but it's a trade-off. Do you want to spend the time to do it? You have a risk. What happens if you do something improperly? That could be fatal, like actually be fatal if you driving in the car and any loved one or friend that you're taking care of by driving the car, that could be fatal. So you have to make a decision of how are you going to address this thing. One everyday example is if you have ever taken a paper clip, right, and if you bend it back and forth enough, over and over and over again, there's an engineering term called fatigue, where it will break. And so what that's saying is all the components, whether on your car or an airplane, it's designed for being used only so many times. Also, as we think about materials, maybe you have different considerations. Maybe you have thermal considerations in terms of how hot or cold it gets. Maybe you think about the sound, whether you want it to absorb sound or amplify sound. Maybe you think about couldn't think of a good word, but if you think about dampening or like shock absorption, right? What do you want? What sort of behavior, material behavior do you want out of your material? So you go from just looking at the motion of a single point all the way to your everyday products. And there's so many things involved. You can design sort of your proof of concept, right? They say it's like a one-off or the first prototype or one of many prototypes. But then how do you get that to be manufactured? And that usually means you're making it in the thousands, tens of thousands, the millions. The way that they make the first iPhone prototype is very different from how it's actually manufactured. Again, to balance this, it's at a low enough of a cost that the consumer is willing to buy it compared to the other competitors and their choices, but that the company can make enough of a profit to be able to stay viable as a business and pay its employees, so on and so forth. All right, so that's just an overview, and I just want to add at the end, since this is going to be the last episode for now, the importance of understanding motors, okay? So there's a number of videos about motors that I'll reference to. Really, actually making sort of a toy motor is probably the best way to understand it, but that might not be easily accessible. So motors are a good way, and I guess we'll just talk about it a little here. You're taking electricity, all right? You're taking the relationship between electricity and magnetism, and you're getting motion. And where does this electricity come from? It comes from a battery, which takes chemical. All right, so this right here is called a battery, okay? Now a generator, you're just going in reverse, all right? So you have some sort of motion, usually a rotational motion, and then you're storing electricity. Okay, so very important to understand those two things. I think I've given a good overview, so let's just sort of go reverse here. This was sort of a summary, but just looking at how we understand physics and engineering, and then going into the real world. Talked about simple machines, which if you have this mindset, you'll analyze so many things around you. Forces and torques. And then talking about different forms of energy. And then finally to our big picture, big concepts. So thanks for listening to these 5 episodes. I hope you've learned something. In this day and age, you can Google different things, and there's a lot of good resources out there, but I feel for our classroom and extracurricular setting, it can be a bit overwhelming. So I think all told, these 5 episodes, maybe about an hour or so, add a little more time if you needed to pause and rewatch things. Hopefully this can give you a good overview of things, and then you can dive into particular parts that don't make sense, or maybe there are things that you do want to get into and get more of a quantitative understanding. Yeah, so I hope this is useful. This is just the first attempt at trying to summarize a lot of information. Thanks for listening.